in two legs, single phase full bridge. The same thing could be say for VBC, VCA. You see here 0.61, 0.61. These values coming from here. Now this is my three phase. This is my, as I mentioned, we can use square wave now rather than pulse width modulation. We will use square wave. The same previous equation, just I will multiply by 4 over pi. For that become 0.78. Okay, and the remaining is, you know that each leg have two switch, each switch conduct for 180 degree of the time of the 360, and phase shift between A, B, C is 120. So at the end we will, you see here 120 from here to here. This is B, this is A. Okay, and these are the 60, the remaining 60, and the second one came here and here, and then at the end we have the three-phase output voltage. Let's apply this for the switch utilization factor. Now we know that V switch is VD max, current is I square root 2 IO, and the volt ampere will be V line to line IO multiplied by square root 3. How many switches we have? 6 switches. So if I substitute in the formula and I did the calculation, I got again 1 over 8 MA. It is the same in single phase and in anything. You see, between this point and this point. Okay, because I need it here. It's 1 over 3 because the same, so 3 times it repeats itself. VAN, VBN, VCN. And if I come here to find V as example, I will use A. It will be AN, VAN. Okay, and I substitute for VNN by this value here. I got VAN 2/3 is VAN minus 1/3 VBN and VCN, the DC wire. For ripple in current, the same discussion done before is repeated again here, but see the signal, the output signal here. It is no square wave similar to the previous one in single phase. So when we subtract, we go this ripple. Still ripple is high. Okay, the high value here in the square wave. For let me say the pulse width modulation. This is pulse width modulation. Also, we did the same discussion before. Apply here, but see the fluctuation is high again, higher even than single wave. And the peak increases a bit. For DC side current, you remember when we discussed for single phase, we mentioned that there are two components. One is the DC component of the DC current, rippling current, DC current, and the second one is AC component, which have double the frequency, fundamental frequency. Now, if I apply the discussion here, this is the DC current voltage, VDID. And this is the AC, VAIA, VBIB, VCIC. And when we substitute for them and simplify, we will get one component, which is DC component. There is nothing changed here. There is no omega, which tell me that the AC component has been cancelled, which is good. Now for square wave, you need to keep in mind we connect in each leg two switches, and there are two diodes connected anti-parallel with them. Okay, so this is the voltage as I explained before, but see the current here. Okay, on the DC side, this is the square wave, and this is the fundamental, as you can see here. But see, for leg A, the positive current to be conducted by TA from this point to this point. What about if there is negative current at that time? It will be conducted by DA, the opposite direction. For negative current of leg B, TA negative will conduct, as you can see here, from this point to this point. What if there is negative current to follow in the circuit? It will be conducted by TA negative, DA negative. The drive connected in anti-parallel with TA negative. One more issue regarding the switching of the three-phase circuit inverter circuit is impulse width modulation. We will see sometime that three switches conduct at the same time. As example, here at this situation, you see if I go up, okay, here is positive, here is positive, here is positive, all of them conduct at the same time. This means that there is short circuit occurred across the load in this way. You see here, all of them connected at the same time, and this make short circuit. These are short circuited the load, or the negative switches conduct also do the short circuit. You can see here it is one pulse produced, one pulse. Okay, so sorry, here it was 0.4, 0.2. They came to say that okay, these let me say signal in the middle, they are large and close to each other. Why don't we stop switching at this time? So they modify it. When you stop switching, carrier gone here in this period, switching is stopped, so the control signal is larger, the pulse will be 1. They saw that this affects the harmonics also, and it's, by the way, when we reduce the switching, we reduce the losses. Okay, so this is the point. We want to reduce the losses here. Displacement. In displacement, what we do now, you see here, this is the normal VA and VBN, VAB, we go the square wave. But if we make phase shift between them, as example here, alpha I call it, we discussed it before. When phase shift happen between A and B, we will find that the pulse change, the output changed, okay, and alpha came as a variable here. We can't control alpha, which is the phase shift, we control the output voltage. I will stop here to continue next session. Thank you.